All right, lesson 7-5. We're going to be talking about exponential and logarithmic equations and inequalities, mainly just the equations part. And you are going to need to remember your properties of logarithms that are in 7-4. Those are on page 512, but they should also be in your notes. Okay. So first let's talk about how to solve exponential equations, and then we will solve and check. Okay. So here's our problem. Our problem is that we have to solve for x, but x is in the exponent. All right, and it's actually in the exponent on both sides. So the first thing I want to think about is if I tell you that 3 to the x is equal to 3 to the second, well, this is equal to 9, right? 3 squared is 9, which means that in order for this side to be 9, x would have to be 2, correct? So x is 2. If you notice, if your base is the same, then that means that your exponents are also equal. Okay? So I need to think about a way that maybe I could write these with the same base. So I have to think, well, can I write 8 with a base of 2? Well, if I say 2 to the third power, that is the same thing as saying 8. 2 times 2 times 2 is 8. I still have to remember to put the x on the outside there. This already has a base of 2, and that's raised to the x plus 6. So now I have to say, okay, well, I have a power raised to a power, so I would multiply those. So this is really 2 to the 3x is equal to 2 to the x plus 6. Now, if you will notice with me, this has a base of 2, and this has a base of 2. So that means that their exponents are also equal. So if the bases are equal, the exponents are equal. So since I'm solving for x, I can just get rid of the bases because I just want to know what x is. So I'm going to set 3x equal to x plus 6. Now it's just an Algebra 1 problem where I solve for x. So the first thing I need to do is get my x's together. So I'm going to subtract x from this side. So that gives me 3x minus 1x, which is 2x. All right, so once I subtract the x, I've got 2x equals 6. Then I just divide by 2. 6 divided by 2 is 3. So x is 3. Now I want to check myself. All right, so we'll call this the check part. So I have 8 to the x equals 2 to the x plus 6. So this is just my original problem. And I'm going to plug in 3 where the x's are. So that gives me 8 to the third equals 2 to the 3 plus 6. So 8 to the third is 512. This would be 2 to the 9th. All right. And 2 to the 9th power is 512. So I see that both sides are equal, so therefore I know that my determination that x equals 3 is correct. All right, number 2. Again, if I can write them with the same base, that's what I want to do. Okay. So I have a base of 3 here. That's a prime number. Can I rewrite 27 with a base of 3? Well, I think that I can. 27 is the same thing as 3 raised to the third power. Notice that your bases are now the same. So therefore I can set my exponents equal to each other. So I have 2x equals 3. I solve for x, so I have to divide by 2. So I get x is equal to 3/2. So again, I'm going to check myself. So I write down my original problem. 3 to the 2x equals 27. And I'm going to plug 3/2 in for x. So I get 3 to the 2 times 3 over 2 equals 27. 2 times 3/2 is just 3. So I get 3 to the third. And I know that 3 to the third is 27, which shows me that both sides are equal. So therefore, x equals 3/2. Okay? All right, number 3. So I have a base of 9 and a base of 27. Neither of those are prime numbers. Okay, so I have to think, is there a number that they both are divisible by, or that I could write with the same base anyways? And I can rewrite 9 with a base of 3, so that would be 3 to the second power is the same thing as 9, and I still have the 8 minus x on the outside. And then I've got 27 I could write with a base of 3 as well. That's the same thing as 3 to the third power. And then I have it raised to the x minus 3 on the outside here. So all I've done is I've rewritten 9 as 3 to the second, and I've rewritten 27 as 3 to the third. So since I have a power and another power, we need to multiply those. And notice that I have one thing on the inside and 2 on the outside, which means you're going to have to distribute. So this would be 3 to the 2 times 8 is 16. 2 times negative x is negative 2x. Same thing on this side. This would be 3 to the 3 times x is 3x. And 3 times negative 3 is negative 9. Now if you notice, you have a base of 3 on the left and a base of 3 on the right. So now you can set both of your exponents equal to each other. So 16 minus 2x equals 3x minus 9. So now I just have to solve for x. So the first thing I need to do is get my x's together. So I'm going to go ahead and add 2x just because I like positive numbers better than negatives. So that leaves me with 16 equals 3x and 2x make 5x minus 9. So now I have just the one x to solve for. So I'll just do my simple solving. 16 and 9 are going to make 25. And then I have to divide by 5. So I get that x is equal to 5. And I'm not going to take the time to do it right now, but again, I would check. So I would take and plug 5 in for this x, and I would plug 5 in for this x, and I would see if that equals on the same side. All right, and it will. All right, number 4. Okay, so number 4, I'm trying to think if I could maybe write 200 with a base of 5, because 5 is a prime number. So I have to think, okay, is there something I could write 200 where I have 5 to some power? And there's not. So I'm going to have to do this a different way. So I have to think about my logarithmic properties. So I have an x and an exponent, and the problem is that I need to get the x out of the exponent so that I can solve for it. And you're going to see this a lot later on where you have an x and an exponent, and you have to remember how to get it out. So we have a property that says if we have a log in front of this number right here, that we can pull the exponent down in front. So what I'm going to do is I'm going to log both sides. And remember, it's important that you do both sides because if you don't, you're not balanced. So I'm going to take log of 5 to the x minus 2 equal to log of 200. It's very, very, very important that you do it to both sides. So now that I have a log, that property tells me that I can take that x minus 2 that's in the exponent and I can pull it down in front. Now you want to make sure that you put it in parentheses. So you've got x minus 2 equals, times log 5 equals log 200. Notice now that my x is no longer in the exponent, it's now in front. So it's kind of the same thing that we were doing the other day. We have to solve for x. Well, we just have this one x. So I have this whole thing being multiplied by log 5. So I'm going to divide by log 5. Excuse me. Both sides. Remember, what you do to one side, you have to do to the other. So these two cancel. That leaves me with the x minus 2. Since there's nothing else being multiplied by that, I don't need the parentheses anymore. I can drop them off. All right. Now, I would tell you to go ahead and divide these, but don't do that. Okay. So you got log 200 divided by log 5. We don't want to do anything until the very end, and then we'll put it all in at the same time. Okay. So now, all I have left is to get rid of this minus 2, so I will add 2. So I get x equals log 200 divided by log 5 plus 2. So in your calculator, this is exactly what you are going to put in. Log 200 divided by log 5. So you need to get your fraction. So you've got log 200 divided by log 5. Make sure you move over, and then you've got plus 2. And we get 5.29, blah, 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 blah. You can round to the nearest hundredth. All right, that's the second one. So I'll look behind the 9, and I see that that is less than 5. So I will round that to 5.29. All right, and since it's not exact, we will use little squiggly equals. That means approximately 5.29. And I do want the squigglies. All right, let's take a look at another one. All right, so again, there's no way that I can write 15 with a base of 2. So I notice that I have 3x in the exponent, and if I log both sides, that will allow me to bring it down. So I'm going to log both sides. So I have log 2 to the 3x equals log 15. I have a property that states if I'm logging something with an exponent, I can bring that exponent to the front. So I will say 3x times log 2 equals log 15. All right, and I notice that x is being multiplied by 3 and by log 2. So I can actually take both of them at the same time. So I will divide by 3 log 2. That cancels the 3 and the log 2, so I'm left with x. And I'm going to plug this in my calculator, so I'm going to say approximately. So if I plug that in exactly like it looks, I'm going to get 1.302. So I will just say 1.3. You can put the 0 on. That's fine. All right. And this one. There's no way I can write these with the same base. 5 is a prime number, and 4, the only thing I could write with its base would be a 4 or a 2. So again, I notice that x is in the exponent, so I'm going to log both sides. All right, I can pull this exponent to the front. So I get x minus 1. Remember, put that in parentheses since you're taking all of it times the log 4. Equals log 5. I'm trying to get x by itself. It's being multiplied by log 4, so I'm going to divide by log 4. And again, we're not putting that into the calculator until the very end. So my log 4's cancel. I have x minus 1 equals log 5 divided by log 4. And then my last step is to add the 1 to get x by itself. So I have x is approximately, if I plug this in exactly like it looks, I'm going to get 2.16 if I round. All right. I'm going to skip that one for right now. So your numbering will be a little bit off, but I will let you guys fix that. Okay. So let's do this one. We're solving logarithmic equations. All right. Notice there's already a log in this. Okay. And this looks a lot like some things that we did earlier in the chapter. So here's the thing. I want to get rid of the log so that I can get x into something that I can solve for. Okay? So to get rid of the log, we just need to rewrite this in exponential form. So remember, you always start with the base. So I've got 3 to the second power equals all of this mess right here, x minus 5. All right? Now I no longer have the log because I wrote it in a different format, but now I can solve for x. I know that 3 squared is 9. And then all I have left to do is add 5. So I get x equals 9 plus 5, which is 14, and I am done. All right? Number 9. The first thing that you should notice is that there are 2 logs. We never want to have 2 logs. So your first order of business is to rewrite this as 1 log. So if you notice, these both have a base of 10. Remember, if there's no base, the base is 10. And you are subtracting them. Therefore, you can write this as 1 log, so a log base 10. And when you're subtracting, you take these 2 numbers and you divide them. So you have 45x divided by 3, and that's equal to 1. So now you have 1 log. Now you want to get rid of that log so that you can solve for x. So you rewrite it in exponential form. That would give you 10 to the first equals 45x over 3. So whatever you can simplify, you need to simplify. So if you notice, 45 divided by 3 is 15. 10 to the first is just 10. So this gives me 15x. Now all I have to do is divide by 15. And I need to reduce that. So that gives me x equals 2/3 because they both divide by 5. Okay? Number 10. So my first order of business is I notice that I have 2 logs. So I want to try to rewrite that as 1 log. I notice that they both have a base of 4. I am subtracting, so I can rewrite this as log base 4 of 100 divided by x plus 1. And then on the right-hand side, I just have 1. So now that I am down to 1 log, I want to rewrite this in exponential form. Okay, so I would say 4 to the first equals 100 divided by x plus 1. All right, 4 to the first is just 4. So now I have to solve for x. Well, the problem is that x is in my denominator. So we talked about this the other day. I need to get it off the bottom, so I will multiply by the x plus 1. Make sure you include it in grouping symbols since you're moving it. So I would say x plus 1 times this 4. I cancel over here, so I'm left with x plus 1 times 4 equals 100. Since x is included in this parenthesis and the whole thing is being multiplied by 4, I will divide by 4. You could have distributed, but it's not going to work out well for you. It's easier to do it this way. So I get x plus 1 equals 100 divided by 4, which is 25. It's kind of like a dollar divided into 4. All right, so I will subtract the 1, and I get x is equal to 24. All right, number 11. All right, I'm going to give you two options of how you can work this one. All right, we'll go option number 1, option number 2. All right, you could notice you already have one log, so you don't have to do any combining there. But you do notice that you have an exponent. So you could pull this exponent to the front of your log and do 4 log base 5 of x equals 8. I can't rewrite my log yet because there's something in front of my log. So since 4 is being multiplied, I'll go ahead and divide by 4. So that gives me log base 5 of x equals 2. Now that log doesn't have anything in front of it, I can rewrite this in exponential form. So it's a 5 to the second power equals x. And I know that 5 squared is 25. I like that way the best, but I think that you guys will probably like this way. So again, you just have one log. There's nothing in front. So you could just immediately rewrite it as 5 to the 8th equals x to the 4th. All right. 5 to the 8th power is 390,625. And then to get rid of a 4th power, you have to 4th root. Okay, and remember in your calculator, you have a button for that. If you go to Math, this little option down here with the X, option 5. All right, I can put a little 4 out there, and then I can put 390625, and it tells me that it is 25. All right. Whichever way you like, those are two options for you, just because you had that exponent up front. Okay? All right, number 12. Okay? So I noticed that I just have one log. I have no exponent, so I could just go ahead and rewrite this in exponential form. So 6 to the negative 1 equals 2x minus 1. Got to do all of it. 6 to the negative 1, if you put that in your calculator, it's going to tell you that it's 1 over 6. All right. So then I'm just solving for this x, so I'll have to add 1. All right, 1/6 plus 1 is 7/6. And then I'm going to divide by the 2. That's the same thing as multiplying by a half. Or in your calculator, you can just say 7/6 divided by 2. It'll give it to you. And that's going to tell you that it is 7 over 12. All right, number 13. So I notice that I have 2 logs. I need to try to write them as 1. They do have the same base, and I am adding them. So I will keep the log base 12. But then I have to take this and multiply it times this. So I have to distribute. X times x is x squared, and x times 1 is 1x. Now that I'm down to 1 log, I can rewrite this in exponential form. So I have 12 to the first equals x squared plus x. Now, in your mind, you should notice that you have a squared term, a term that's not squared, and then this number over here. So this is really just 12. So I'm going to subtract the 12, and then that gives me a trinomial. And I know how much we love trinomials, so I'm going to factor that. All right, so remember a minus in the back means that you have 1 plus and 1 minus. We have to have an x times an x to get the x squared. And I need two numbers that multiply to make 12 and subtract to make 1. That would be 4 and 3. And since there's a plus in front, the bigger number, which is 4, will go with the plus. All right, and then your last order of business is that you set them equal to 0 and solve for x. So I would have to subtract 4. So I get x equals negative 4. And I would have to add 3. So I get x equals 3. Now we need to stop for a moment and think about these. I cannot take the log of a negative number. So the minute you plug in negative 4 for this x, you're taking the log of a negative 4. And you can't do that. Okay? And so, therefore, negative 4 would be what we call an extraneous solution, meaning it's kind of a solution, but then it doesn't work when you put it back in your problem. So we will leave this one off, and this is the only one we will count as an answer. If you put the other one, you're going to get the whole problem wrong. Okay? So be very careful about that. And we are going to stop right there for the day.